Okay, so the next lemma is going to seem kind of weird, but it's also again very helpful. And it, in a sense, let me state it, and then I'll tell you what it's saying. Um, so suppose you have a tower of extensions with four terms, so k and l and n and m. L over k, this first guy here, this one's finite. N over k is the normal closure of L over k, which is you take and you add in the missing conjugates that you need. That was our recipe from the previous video. If you further have extended N by M, and you had a k monomorphism from L to M, then what must happen? Then the image of L actually is contained in N. So what this is saying is you can't leave N. So let me draw increasing sequence of circles. So here's our extension here, and we have this map tau that is a map from L, the green area. It's a map to M, the big guy that has all of them. What this is saying is L can move around, but it can't actually leave N. L, the image of L, is stuck inside of N. You cannot escape the normal closure. So for this reason, I like to think that this lemma is saying that normal closures are kind of algebraic boundaries. You can't leave them with a monomorphism. It's not possible. You always must stay inside of them. And that's what this lemma is saying. Or at least that's how I like to think about this lemma. Normal closures are algebraic boundaries. Proof. Let's take some alpha in L, and let's let M alpha be the minimal polynomial over K. Again, L over K is finite, so every element is algebraic, so it has a minimal polynomial. Then M of alpha is 0, M sub alpha of alpha is 0, and tau is a K monomorphism. Tau fixes K. So tau of M alpha of alpha, if we were to apply it to that, which is to apply it to the coefficients of M alpha, and then also to alpha, well, it doesn't mess up the coefficients of M alpha because it fixes the coefficients. So that's just applying it to the input. And M alpha of alpha is 0. The image of 0 is always 0. Okay, so tau of alpha, wherever tau sends alpha, is also a 0 of M alpha. But N is normal. And if you have 1, 0, alpha, then you must have all the zeros. And that's it. If you have any element of L, tau must send it to N. It cannot send it outside of N. Okay, so normal closures are kind of like algebraic boundaries.